Welcome to another interesting session in the math class. Today, we look at an important topic in statistics called as the normal distribution, which is one of the most important statistical distributions that you would be studying in statistics, right? To know what a normal distribution is, let's take the whiteboard and try to understand that right away. Let's say you're plotting the height of people in a country, right? Or maybe let's say the weight of people. So let's say you plot a graph that looks like this, right? Let's say this, like the weight starts from, like, say 20 kg, goes to, like, say 40 kg, 50 kg, and then goes to, like, say 100, 120, 180 kgs, right? Let's say we have this range of weight. So you would definitely appreciate the fact that people who range in the extreme weights, right, like 20 kg and 180 kg, they are going to be less in number compared to people who have weight as 50 kg or maybe, like, say between 40 to 60 kgs, right? They'll be the most frequently occurring population. Don't you think so? That's true in the world. Even with height, right? Even with height, that's the case, right? Like people who have a height of between, like, say 5 to 6 feet, they're going to be the maximum in number than compared to people who are, say, just 4 feet height or, like, say 7 feet height, right? So this kind of phenomena is observed in especially all cases that we see around the world, right? Natural phenomena, or maybe in economics and physics and social sciences and astronomy, everywhere, right? So that distribution, which represents the real world in the most commonly possible way, is called as a normal distribution. All right. So it typically looks like this. It's like a bell-shaped curve. All right, it's a bell-shaped curve. And then if you want to be idealizing this distribution, right, then what's going to happen is that these are the characteristics. So it's the first thing is it's like symmetric around the mean, right? Symmetric around the mean. So if you see this value is the mean value, which is also the median, because if you observe the x-axis, it's exactly equidistant from this first point and the last point, right? So this is also the median. And if you observe, this value has the most frequency occurrence. So if you plot weights, right, weights of a sample, then this weight has less frequency. So the y-axis is frequency and the x-axis is the metric, right? So the frequency of the weights increase vertically along the y-axis. So if you observe, this point has the max frequency, which means that this point is also the mode, right? The most frequently occurring point. So the mean, the median, and the mode, they are all equal in a normal distribution, right? Just remember this. And that's why this distribution is symmetric around the mean. Now, another characteristic of the normal distribution is that it has been found empirically that this is the mean, right? So the other thing is this normal distribution can be completely represented using the mean, which is represented by mu, and the standard deviation, which is represented by sigma, all right? So mu and sigma. So it has been found that around 66% of the observations, 68% of the observations lie between plus and minus one standard deviation from the mean. So this is the mean, right? So one standard deviation plus and minus is this much. This is plus 1 standard deviation. This is minus 1 standard deviation. So these observations, you can say it in the shaded region, right? This shaded region, this much. They account for around 68% of the total observations, all right? Thereafter, around 95% of the observations lie within plus and minus 2 standard deviations from the mean. So like this and this region, right? If you look at this region here, that region accounts for 95% of the observation. That is 2 standard deviations. And then 3 standard deviations from the mean, just minus 3 and plus 3. This region encompasses around 99.7% of the observations. All right. So that's another important rule of the normal distribution. So that's in short the normal distribution. Now using Z scores, you can convert this normal distribution to a standard normal distribution. How do you do that? We would see that in the next video. All right. So until then, stay tuned and keep learning from this channel. And if you like this video, please comment at the bottom and subscribe to the channel, all right? And spread the message among your friends. All right, so I'll see you in another video. Until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye-bye.